Finally, we understood how to get the IP addresses, right? Now we'll see a concept called subnetting, and we'll see the purpose for it. Why subnetting is required, I will tell you. You have an organization, and this is your, let's say, I can say CIDR notation of your network, okay? So this is one of the IP address possible in your network. Second one, so 24 bits for prefix. So 24 bits for prefix means your network part has 24 bits, we cannot touch them. So blindly remember from now onwards, our authorities gave us 32 bits, out of them 24 bit pattern whatever they have given, don't touch them. Only you have a chance or you have a right to touch the remaining bits, which are nothing but 8 bits. 32 minus 24 is 8. 8 means what? 2 power 8 patterns. So 256. So there are 256 patterns given for you. Out of them, 2 we have to use for, one for network address, second one broadcasting. That's why we have only 254 addresses. Now with these 254 addresses, then you want to form one, subnetwork, otherwise subnet. Why? Why you want to do subnetting? What is subnetting? Everything you can understand if you understand the purpose first of all. The reason for this subnetting concept is like this. Example, let's say, so you created a network, okay? Otherwise, you just thought of creating the network with 254. Sometimes, I say, so you are creating a network with 256. Don't mind. We know that, only we can have 254 systems, but sometimes, in a rough way, otherwise, in a loose way, we say 256. But exception is only 254. We can use only 254. Okay. See the situation. You have 254 devices and you connected as a network. Then the first problem is some of them are like-minded networks, I can say, like-minded devices. Otherwise they are very important and they are having lot of information maybe, and you want to treat them separately, maybe because of security purpose. Otherwise they are very priority wise, they are very important for you. That means lot of information is exchanging between these nodes. Then you want to group them somehow. So finally, so grouping is important sometimes, correct? Example, let's say you have these 254 devices on that. So some 4 are servers and you want to connect them separately. Otherwise, some 20 systems are, some private systems. You want, otherwise they have a separate purpose. There is a lot of communication between only that 24 and you want to monitor them. So there are so many reasons. That's why whenever you have that kind of purpose, then divide them into groups. So dividing groups is sometimes important for some of the manipulations, everything. So at this moment, because we are studying network, when you have a network, then we can divide it into some subparts. Whenever you want to do that, yes, it is possible. At this moment, 254 network you have, right? 254 device network. So out of that, we will see how to divide it into 2 parts first. Example, really you want to divide it into 2 parts. Okay. So forget about that these 2 exceptions like host part, that network part and broadcast. Otherwise, what is your capacity? That means we focus on how many addresses we have. 256, right? Then we are going to divide that 256 addresses into 2 parts and we are going to do subnetting. That means your network is divided into 2 parts such a way that one network can have 128 addresses and second network can have 128 addresses. How to separate it we will see. Okay. So first question, student ask immediately, sir, you have only 254 addresses. No, I have 256, but out of them 2 I cannot use. Similarly, that 256 I divide into 128, then slowly you realize that in this 128 also 2 addresses will be special. In this 128 also 2 addresses will be special. Okay, slowly you understand that. Now our focus is how to divide our network into 2 parts so that one network can use 128 addresses, second network can use 128 addresses. We will see. For that, what is the CIDR notation? This CIDR notation is for a network with 256 addresses, right? Now I want to have 2 networks and I want to have a CIDR notation for the first network whose capacity, otherwise who wants 128 addresses. Another CIDR notation I want for what? Another network which is going to have 128 addresses. Okay, let's see that. It's very simple. So however, you cannot touch that, your network part. Your network is having 24 bits that is given by authority, you can't disturb. So you are doing these things locally without telling, your that authority. So no one is aware of this thing. So that flexibility you have. For that, what you have to do is only that host part we have to disturb. Okay, so let's focus on that. That's why I write 10.192.65, which is nothing but prefix part, otherwise network part, as it is. Only this 72 part I am going to disturb. First of all, let me write a binary pattern. Before that, let me ask a question. This is one of the IP address in your network, right? That means in one of this is one of the binary pattern or IP pattern which you got out of 256. Now you tell me what is the starting address of your IP addresses? Simply 10.192.65.0. Why? This is, did you remember? The last 8 bits are going to be yours, host part. If I write all zeros, that is going to be start. If I write all ones, that is going to be the last address. We know that. That's why. So this is the starting address. The last address will be 10.192.65.255. Okay. Now I am going to divide them into exactly half. First half will go to this network, second half will go to this network. For that, what I do is I do simply, I take the first bit from the host part. Okay, I write 0 and I write 1. I simply say that 0 followed by anything is nothing but network number 1. 1 followed by anything is network number 2. Okay, in that way we can divide. For that I am using 1 bit. Okay, from host part, especially most significant bit, remember. So this is the way we can do it. If I do that, what is the name of the network? Simple. So from now onwards, this 0 is also part of your network. Okay, this is host part. How many bits? 7 bits. Here also in the second network also, now host can have 7 bits. Let's ask so many questions. Question number 1. What is the starting address of this subnetwork? Simple, 10.192.65. Okay, so here already you know that the given addresses are, we have addresses 0 to 255, right? Now let me ask question number 1. What is the pattern for which pattern is given for this network number 1? It is up to you. Let me focus on 8 bits first. 1 2 3 4 5 6 7 8. Okay, just put 0 and just give that to network number 1. You simply say that, my dear network number 1, you can alternate, otherwise you can vary these positions. How many different ways you can vary these positions, that many addresses you are going to have. So how many different ways these 7 bits can be varied? 128 ways. So that 128 is going to be this network's addresses. So I write like this. In CIDR notation, how we write it? Did you remember CIDR notation can be used and for any network, right? So we write like this, 10.192.65. One of the address we write, okay, one of the address 65 dot. If I take all zeros, that will be one of the address in that network, slash. Now tell me, what is the prefix part for this notation, for this network? In this network, how many bits for network? 8, 8, 8. This 24 already network. 1 bit we just took from host part. That's why I can say that simply 25. Okay. Similarly, second part, 10.192.65. Write any of the address from it. Tell me one address from a second network. How to form second network? Simple. The first bit is 1, right? Now remaining 7 bits you can vary. So if I write all zeros, it is going to be one of the address of second part. Tell me what is it? 10.190.65.128. This is going to be one of the address in second part, and that is also going to have network prefix of 25. 24 as usual plus 1 bit extra. So 25, 25. These two will be CIDR notations for two subnetworks, 1 and 1. Okay. Now, sir, I would like to focus on this CIDR network 1, and I would like to know what is the starting address and what is the ending address and how many addresses we have in this network. I want to know, sir. Simply know it. We have a formula for it. Let's use it. Okay. Let's begin. First of all, the CIDR notation is 10.192.65.0/25. Question number 1. What do you want to know? How many addresses are possible in this sequence? Simple. Go to host part, go to this prefix part, 25. Get host part, 32 minus 25, 7. So apply 2 power 7, which is 128. That means this notation or this system has 128 addresses for you. What are they? Do you want to know? Then simply how to write the first address? We know that 10.192.65. Blindly go to your host part. Your host part is like this: 1 2 3 4 5 6 7 8. This is host part, right? This is network part. In the network part you have already 0, right? Okay, otherwise what you do is, first of all you write this IP address blindly: 10.192.65. This is one of the IP address you got in your network. Now identify host part 7 bits. Keep everything 0, already they are 0. Then automatically you get starting address. Now keep all ones. What happens if you do that? You are going to get last address in that network. It would be 10.192.65. It is like this part is 0 again, right? 0 7 ones, not 8 ones. Why? This 0 is now belongs to network part. That's why 0 followed by 7 ones is nothing but, I think, 127. Okay, that means 10.192.65.0 to 10.192.65.127 are going to be the addresses in the network number 1. Sir, I want to know the network 2 addresses. Yes, you can get it. See here. So first we take CADR notation for that. What is that? 10.192.65.128 followed by 25. Okay, let's start. First question number 1. So how many addresses we can have in this network? Simple. It depends on 25. Already we know that. So in the first part also this was 25. Whenever it is 25, you get 128 addresses. Here also 128. First question is trivial. Second question, what is the starting address in this network? Simple. 10.192.65. Now first you write a pattern. 128 means what? 1 followed by 7 zeros. 1 2 3 4 5 6 7. Question number 1. Sir, why are you writing binary pattern for only this first octet or last octet, whatever it is? I will tell you. This is network part. We are not disturbing. Network part. This is host part according to the world, correct? World gave us 8 bits for host part. In that, this bit is variable. We can keep anything, but I am keeping 1 so that I can form one another network. Okay. If I keep 0, that is going to be the first network. It is done. Now, if it is 1, it is going to form a new network. But these 7 bits are going to be host part in that subnet, right? Host part. Okay. Question number 1. So in this host part, there are 7 bits, right? Then what is the starting address? Starting address is very simple. Write all zeros. Already they are all zeros, right? That's why you are going to get 10.192.65.0. But we have first bit 1, right? Then it would be 128. So this will be the starting address. It's quite easy. Now make all ones in the host part, 7 bits only. Then you get 10.192.65. See, already 7 ones, this one, 8 ones, it would become 255. Okay. So this will be starting and ending addresses of this subnet. In that way, we can divide our network into 2 parts, and it is local for us. That means, so we are logically dividing it into 2 parts. But for outside world, it's not compulsory to inform. If you want to inform that, you can inform. I will tell you how to inform. But at this moment, you remember, generally for our sake, that means for our network sake, we did it. Okay. We can do it in 4 parts also. Now we'll see one more example where we are going to divide that into some unequal parts. Here we have seen, equal parts, right? 128, 128. So now we start with some requirement like, I have a network and I want to divide it into 3 parts such a way that first network should have 100, second network should have some 20. In that way, if you have such requirement, how to divide, for that, how to fix this, network part, we will see. How to create addresses, we will see. Okay. Now we'll see one example and we try to do subnetting. An organization is granted block of addresses and 14.24.74.0 is the representation for that, and /24. We know one thing, 32 minus 24 is 8. That means 8 is going to be the host part. 2 power 8 is 256. So we are going to get 256 addresses. With that, we have to create subnets of 120, 10, 60. Now, how to do that, we'll see. To have, subnet of 120, Then how many bits are required for host part? Because how many addresses are required? 120, right? So using the 7 bits, we can generate 128 addresses, correct? That's why host part is going to be 7 bits. The last 7 bits. And one more thing, according to our authorities, we can't touch network part. We never touch it. First of all, identify the network part. 14.24.74. 24 bits are network part officially. Now we have 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. This 8 bits we can use in any way. Okay. Now using that, what we do is, since we need 120 systems, otherwise 120 addresses in one network, then for that 7 bits are definitely required, correct? And one more thing, remember. So one network should have all consecutive addresses, remember it. Okay. That's why. And that's why we use 7 bits, 1, 2, 3, 4, 5, 6, 7. These 7 bits, if I use, and what about this one? You can use here 0, otherwise 1. Okay. So 1, 2, 3, 4, 5, 6, 7. What I want to say is, you can create in the first level 2 networks, 14.24.74 dot, and the remaining octet I don't know, but in the remaining octet first bit is 0 for one network, first bit is 1 for another network. So finally I created 2 networks. Let me take this as network. Okay. Now, sir, what about the 7 bits? That's why variable part. Now you can vary like anything. If you vary like anything, then how many patterns we can generate? 128. So that will definitely serve this purpose, this subnetwork purpose, right? 120. Done. So now I got one subnet for this one. What is that? 14.24.74. So tell me one IP address in this one. Simple. So you can keep anything here. Let's keep all zeros for simplicity. So you are going to form one such address. So that will be 0. I can say this one is network address for this subnet. Okay. Second thing, what is the prefix part? Prefix is 8, 8, 16, 8, 24 plus one more bit we used, right? 25. Okay. So host part is 7 bits. Done. Successfully I have completed this part. What about this remaining thing? We have now requirement for 60 and 10. But I have pool of addresses, you see, 128, correct? Just remove it. This is done. Let me write the name of the address here. 14.24.74.0./25. This is the subnet. Second subnet. One is 60, one is 10. What you do is, this time, you take the remaining addresses. These addresses are available now, correct? On that, so but we need 2 networks, right? Then one is 60, one is 10. Then can I do one thing? Use 6 bits. Then only if I use 6 bits for host part. So this is, let's say, network part. These 7 bits are host part. In that host parts, how many bits should be variable so that 60 addresses can be generated? 60 means, 64. What is 64? 2 to the power of 6. That means, remember one thing in this our model. So the number of addresses we can generate either 2 power 1, 2 square or 2 cube or 2 power 6 in that way. Always it should be 2 power. That's why what is the nearest 2 power to 60? 2 power 6. So what you do is, you have 7 bits, make 6 bits variable. Okay, let me do that. Especially which 6 bits? These 6 bits. Last 6 bits always. 1, 2, 3, 4, 5, 6. That's it. Now what about this one? You have option now. Then you keep here 0 one time, 1 one time. If you keep 0 here, that is going to be one network. If you keep 1 1, that is going to be another network. So this will be host part, 6 bits. Okay. Now what I want to say is, blindly keep 14 as it is, 24 as it is, 74 we can't touch them, the 24. Now in our host part, by fixing the first bit to 0, I created a network that got 128 addresses which are given to this network. Now after that, after keeping 1 here, I created again 128 different addresses, correct, with 7 bits. So that 128 I am dividing into 64, 64. So that sum of 64 I can give here, another 64 I can give here. Of course, this fellow doesn't need 64, but what to do? Your requirement is only 120, 60, 10. Then that's remaining 64 we can give to that. Sufficient or not is important. Okay. So for that, let's focus on the first thing, this one. how to give network address to this one? Simple. Already this is fixed. 1. Sir, I want 0. Already we have given 0 to him. That's why 1. Okay. This 7 bits. But don't use all 7 bits for you, because you can't vary all 7 bits, because we have to give some patterns to here. That's why. So your pattern is 1 0. Your friend's pattern is 1 1. Remember it. Okay. So 1 0 is for you. This is also like now network part. Now remaining part 6 bits, happily you can vary. Okay. Sir, can I write all 6 zeros? Yes. Then what does it mean, sir? It is nothing but your subnetwork ID. Okay. So let me write that network address here. What is your network address now? 14.24.74. In the last part you see, this is fixed 1 0. Then what is the weightage? 128 here. 128 plus 0, 128 is going to be one network address, second network address. What is slash here? How many bits are in a host part? Host part are 6 bits. 6 bits are host part. Then network part 26 bits, correct? So that's why we write here 26. Third one. So the last one is very easy. 14.24.74. Now 0 for this one, 1 0 for this one. Now keep 1 1, correct? 2 bits. Then remaining 6 parts again you can vary. These are all different from these are all, right? So this we can give to third person. So what is the network ID of this fellow? It would be 14.24.74. So keep all zeros, you get network address, right? 1 2 3 4 5 6, we know that. This is 128, this is 64. It would be 192. So 14.24.74.192 is going to be third network address. 14.24.74.192 slash. How many bits for prefix part? Again same 26. I can say these two are same category, second two, right? Both are using 2 bits in the host part as network. Already we have 24 bits for network part officially. Unofficially we are, on our own we are having 2 network bits for our purpose. 24 plus 2, 26. In that way, so we can have subnetting. But always remember, if you start with 120 maximum first, then after that if you go for minimum values, then definitely easily we can split. Okay, the process will be easy. I'm not saying that if you start with small you can't do, but if you start with small, then sometimes you might not get enough bits for bigger part. Okay, so try to do that on your own, you will understand that. Okay, but process is same whatever the order you take. What we do is we take one more example and we try to create again subnetworks so that you get practice. That's it. Okay, let's take one more example. CADR is given 12.23.35.224. remember one thing, this may not be the network address. Okay, this is one of the IP address in we are given addresses. That's it. So now if you want to know hello, now we'll see one more example. 12.23.35.224/20. Try to hello, we'll see one more example. 12.23.35.224/20. Okay, in this one, remember one thing, this 12.23.35.224 is one of the IP address in the given IP addresses. Okay, CADR just represents IP addresses. Don't assume that this is one network address. I will tell you how to find out the network address. Okay, so given IP address and 20 bits for prefix, then remaining host bits are 12, right? That means 2 power 12 patterns we got finally, which is nothing but 4096 addresses. So this notation says that we have 4096 addresses. One of them is this one, that's it. Okay, if you want to know the starting address, that is going to be network address if you create one network with this entire group, remember. Okay, so that's fine. Up to now we have not created any network, that's why don't talk about network address, correct? If you want to have a network with 4096 addresses, okay, of course 2 are we cannot use, forget about that. Apart from that, if you want to create a network with 4096, then what could be the network address? If you want to know, I will tell you, but not this one. Okay, now if you want to know that, simply remember starting address of all these IP address is going to be the network address. Okay, start. So 12, so how many bits? This 12 is not going to be changed, 23 is not going to be changed, Since host contains 12 bits, 4 from here, 8 from here. That's why 35 I will write in a binary pattern. 35 is nothing but 32 and 3, correct? So 128 is 0, 64 is 0, 32 is 1, and 16 is 0, 8 is 0, 4 is 0, and 1 and 1, 3, right? 32 plus 3, 35 dot 224. 224 is nothing but 192 plus 32. 192 is nothing but 128 plus 64. Of course, because of experience I am writing. You can convert 224 to binary notation. That's it. You know how to do it, right? So 128 1, 64 1, 32 1, then followed by 0 0 0 0 0. Okay, this is the network address which is given, sorry, one of the address which is given. Now let's first of all identify the host part. How many bits? 12, right? 1 2 3 4 5 6 7 8 9 10 11 12. So up to here. So now if you want to create complete network, then the network address will be simply, here you write all zeros, you get it. Okay, then that would be 12 dot 23 dot. Okay, so 0 0 1, this is nothing but 64, right? 128, sorry, 32. So 32 dot this entire thing 0. This is network address. How I got it? In the host part I wrote everywhere 0. Then you get this one, that is network address. If you create a network with 4096 device, addresses, okay, but that is not our intention. We are going to create this model where 2000 hosts separate, 1000 hosts separate, 500 500. How to do, we will see. So finally you realize that this part is going to be host part. This part we can't touch, right? This part, these 4 bits we can't touch, remember. Okay, now in this 4 plus 8, 12 bits, how many bits you require if you want to create 2000 hosts? If you want to create a network of 2000 hosts, you need 2048 addresses, right? So I'm talking about 2 powers. So 2 power 1, 2 square, in that way go. 2 power 10, 1024. 2 power 11, 2048. That means if you want to have 2000 hosts, then better we have to take 11 bits. So 11 bits we have to take like this: 1 2 3 4 5 6 7 8 9 10 11. So remaining part, in this remaining part, if you see 1 2 3 4 5 bits in this octet and all these bits. But you know one thing, we can't touch these 12 because authority has given this pattern. 23 is given by authority. So this 0 0 1 2, right? These 4 bits also given by authority, don't touch them. Then only we can touch this. Of course we know that only these bits, right? So now that's why this is the only part you can touch for in new network ID, understand? So what I am going to do, you understand, actually authority gave you 4096 consecutive addresses, right? So that's why you got 8 plus 4, 12 bits. See this bit and this 11 bits. Out of 12 bits, out of 4096 addresses, we are dividing now into 2 parts. One is 2048, second one 2048. I will tell you the reason. Because now I got a requirement to create a subnet of 2000. So nearest 2 power is 2048. That's why now initially I divide 2048 2048 and I give 1 to 1 network. Okay. For that simply this bit I use. Okay. So that bit. If it is 0, that is one case. If this is 1, one case. Okay. Just focus on these 12 bits. In this 12 bits, if this bit is 0, then there are 2 to the power of 11 patterns, because 1, 2, 3 plus 8, 11 patterns, right? So this 11 bits can generate 2 power 11 patterns, remember it. If this bit is 1, then again you are going to get 2 to the power of 11 patterns. Now let's fix this bit as 0 and let me generate all patterns. They are nothing but 2048. Agree? Without touching this one, without touching this one, without touching 0 0 1 0 which is given by authority, by touching only this first bit, by keeping it 0 and by varying the remaining 11 bits, I can generate 2048 addresses, because this 11 bits can generate 2 power 11 addresses. So 2048 addresses I am going to give for first network. Okay, so now target is creating this network. Let me copy this pattern here for 2000 hosts. So it would be 12.23.0010 and this is special bit 0 followed by 011 dot 111 5 zeros, 1 2 3 4 5. Okay, there is no significance for host part. Try to understand. Only network part is given by authority. So this host part will be variable. We can keep anything, not a problem. So sir, why we got this weird pattern? Because of this one of the IP address in your network. That's it. But if you want to know what is the network ID, already I taught you, right? What is the network ID? So that is enough. Now here, what is our target? What is the subnet ID of this one? 2000 hosts. That is what we are finding. For that, fix this 12. Don't touch. This 23 should not touch. Here, these 4 also should not be touched because they are given by authority. This part, now this is actually host part. Recall. 20 means what? So 12 will be our host part. 1 2 3 4 5 6 7 8 9 10 11 12. These 12 bits can be anything. Okay. Now in that I am intentionally keeping 0 and I am creating one subnet. If this is 0, then remaining parts can be anything. Then do you want to know such subnet? Simple. Write here all zeros. By writing in the remaining host part zeros, you are going to get subnet. That would be 12.23 dot. So what is the weightage of this one? This is 128, this is 64, this will be 32. Right? So see the value 0 0 1 0 0 0 0 0. Why are you writing 3 zeros here, 8 zeros here? Because we are going to get a subnet now and we are going to find out the subnet ID. How to find out subnet ID? Blindly remember from now onwards. What is host part for you? On that write zeros. For us, host part is this one 1 2 3 plus 8, correct? So that's why that 11 bits should be zeros. Then this one just we kept 0, we can keep 1 also. But if I keep 1, you are going to get one more network. We are talking about one network now. So on that we are writing 0. So this part we cannot touch. This is given by authority. So let me copy 12, 23. So this is 32. 32 plus remaining thing is 0, right? 32. Dot, this is 0. This is going to be the network, which is just we have created one subnet. And what is the that prefix number? Prefix number is nothing but ask yourself question number 1. How many bits you are using for host? 11, right? So remaining things will be network part. 32 minus 11, which is nothing but 21. Now see here 20 bits for host part. Sorry, prefix part, correct? That is what official idea. But unofficially we made 21. That the out of the 21, one bit is ours, right? So from host part we took one bit and we created one network. There is another pattern. What is that? This is what that one bit, right? What if I keep one here? Can I write it? Yes. If I write one here, you are going to have different set of patterns. What are they? We will see. So now what I want to say is 12.23.0010 I don't touch, right? Here I write 1. This is my host part. 1011 dot 111, okay, 00000. Remember one thing, this 1 2 3 plus 8 11, this 11 bits doesn't have any significance because this one of the IP address you have this one, because of that you got this pattern. Really speaking, all you can initially make zeros, not a problem. Now start. Because I kept here 1, now you want to you can have another network now with 2048. Why 2048 you want to know? Simple. Network part, this is network part. Now this is also, this one also become network part. Now remaining host part you see 1 2 3 plus 8 11 bits. That 11 bits how many ways you can vary? 2048 ways. So you are going to get 2048 patterns that can be used for another network. But our requirement is what? 1000 500 500, correct? So let me target 1000. How to have 1000? How to give 1000 from this one? We have how many? 2048. Let me classify now. This is your host, okay? Sorry, network. Now, network part. Remaining 3 plus 8. This 11 is for host part. I want to divide this further, correct? Now, what about this one? Don't touch this one. Already done. This is specially for this 2000 hosts. Now we have 2048 addresses. I want to give 1000 for another network. For that, I would like to give consecutively. How to give consecutively? I will tell you. Simple. How many addresses you have? 2048. Then approximately how many is asking? 1000 nearest 2 power is what? 1024, then 10 bits. 1024 means 2 power 10. So using 10 bits, by varying 10 bits we can generate 1024 addresses. That's why I want 10 bits. Which 10 bits I should take? You simple, always you take from left to right, sorry, least significant bits. 1 2 3 4 5 6 7 8 9 10. So now make this 10 bits variable. What about this one? You can fix it anything now. Already this is fixed, don't touch it, correct? Fixed. Now already these bits also fixed. Now this 0, this is variable. Now you can fix 0 or 1. Case number 1. Let me fix 0 only, but I can fix 1 also. If I fix 0, then what are you going to get is 12.23 dot. So 0 0 1 0 1 0. Okay, this part is now network part. Now remaining thing you see 1 1 dot 1 1 1 5 zeros. Count these bits, you will understand that 1 2 3 4 5 6 7 8 9 10 10 bits. 10 bits can generate 1024 patterns. We need 1000 hosts, we can give. That means, so this part is going to be, host part now. This is, there is no relevance for this 1 1 dot 1 1 dot anything. So now finally here this is variable part. I can have 0 0 dot 0 0 0 0 2 1 1 dot 1 1 1 1. There will be 1024 such addresses. Okay, they all will be one subnet. What is the network ID for that? Now you want to know that? Simple, 12.23. so it is fixed now, don't touch it. What is the value of that? We will see. So this will be 32, this will be 8, correct? Now if you see, this is fixed, 12.23 dot, this will be, what is the value of this one? 40. And if you focus this part, these 2 bits and this 8 bits is going to be host part, and they can be varied from 0 to 255, correct? I mean more than that. But what I want to say is, if I keep all these bits in the host part zeros, you are going to get the network address, right? So the network address will be 001010 all zeros. Then that will become 40.0. So this is going to be network ID for this network, 1000 hosts. So let's write it. So finally here it would be 12.23.40.0. And what is this prefix? How many bits you are using for host? 10 bits, correct? Remember it. Then for network part, 32 minus 10, which is 22. That's why for this one CIDR will be like this. One of the is this is network ID followed by 22. 22 will be prefix. Now we have still 1024 addresses which we have not used. Remember, we had 4096 addresses. Among them we gave 1024 addresses, sorry, 2048 addresses to this network. Then still we had 2048. Out of that, just now we gave 1024 part, right? 1024. Then we have still 1024 addresses. So that 1024 we can give to 2 networks. How we will see? So what is the unused set of IDs we have? What are the unused network? We'll see. So let's summarize it. We have this 2000, 1500, 500 systems. We targeted 2000 first. For 2000 we need 2048 addresses. For that, without touching network part, 12, 23 and these 4 parts. We know that this is a network part, right? 0010 we did not touch. We are only touching this part. Okay, initially it was X. Okay, count it. 4 here, 8 here, 4 plus 8, 12 bits we can touch. So 4096 addresses we can generate, which is initially given. Okay, so 4096 addresses we have. On that, by keeping, now I am taking the first bit out of the 12 bits and I am writing 0. If I write 0 here, still that combination is going to generate 2048 addresses with 0, correct? And by writing 1 here, I can generate other 2048 addresses I use for this networks. Okay, so at this moment, that's why I use 0. If you have doubt, sir, why to use 0, why not 1? Yes, you can do. You can start with 1 also. If you use 1, then for other networks we have to use 0 that bit. Now 0 here. That's why we got 2000 addresses. Okay, so the network address, now we'll see one more time. How to find out network address is very easy. What is network part for you? 12.23. This part 00100, correct? So that means this weightage is 32. But what about this part? This is variable part, host part. Host part, if you keep 0, you get network ID. We know that, right? That's why 12.23.32.0 will be the network part of, otherwise network address of this subnet. Okay, subnet 1 is done, N1. Now N2, target is N2. Now ask yourself, do we have addresses? Yes, we have addresses. How many? How many are gone? 2048 are gone. By keeping 0 here. By keeping 1 here, you get another 2048 addresses. Correct? Sir, by changing this, I can get more, right? We can't touch network addresses, right? That is given by authority. If you touch it, then you spoil everything, because your authority might have given this pattern, this 884, that 20 bits patterns might have given to others also. That's why don't touch them. So only this pattern is for you, 12, 23, 0010. But host part is up to you. Everything is yours. Anything you can change. So that's why now I'm writing 1. If I write 1, then how many different ways this remaining bits can be changed? 3 plus 8, 11. So 2 power 11. 2 power 11 is nothing but 2048. 2048 patterns I can generate. But do I need them? No. After all, I need 1000. So for 1000, minimum number of bits you require only 10. So only use 10, so that other patterns you can use for other networks. That's why what I do is, this bit also I fix so that it is not arbitrarily varying. So I keep 10. That is the meaning of fixing 10 here. If I fix 10 here, sir, why don't you write 0? If you write 0, already is done. That address will become part of this network. That's why write 10. By writing 10, if you want to know how many addresses we can generate, see the remaining host part. 2 here, 8 here. 2 plus 8, 10. 2 power 10, 1024. You need after all 1000 addresses. Yes, perfect. So this will be the network address. If you want to know the network address, 12.23. So only vary this part. Only fix this part, 001010. So this entire thing is going to be host part. If you want to know the network part in this one, if you want to know the network ID, keep everywhere zeros here in the host part. We know that already. If you do that, then this weightage will be 32. This will be what? 8, right? 32 plus 8, 40. So 12.23.40.0 will be the network address of the second one, right? Now if you want to know the prefix for that, simple. What is the host part? 10. What is the next network part? 22. In that way. So here be careful. What is the network part for N1? How many bits you used for host part? 3 plus 8, 11. So 32 minus 11, I think 21. So 21 will be network part. So I can say this is CIDR for this network. This is a CIDR for this network. CIDR is nothing but writing one of the IP address of the network and prefix part uniquely identifies the network. Don't worry. Now third one, we need 500. Do we have addresses? Then which area we did not distribute? Simple. Only host part initially is given for us, and the host part there were 12 bits. 0, first bit 0 gone. Now don't take first bit as 0. So in the first bit 1 and second bit in this 10 patterns are gone. Then what are the other patterns we have? 1 1, right? So that's why I am writing 12.23.0010 we cannot touch. Here I can't write 0 because that is done for network 1. Here if I write 1, no problem, because we have some remaining parts. So some addresses we have in one sequence. So but 10 is already gone for network 2. Then you keep 1 1. Okay. So definitely we have to keep 1 1. If you keep 1 1, then how many other bits we have? XX dot C 2 4 6 8, and here 1 2 3 4 5 6 7 8. Okay, now you have 2 plus 8, 10. So 10 bits. How many addresses you are going to generate with 10 bits? 2 power 10, 1024, correct? Now you need after all 500. That's why what I want to say is, this 10 bits can generate 1024 addresses. Don't waste them, because we have still other requirement. That's why this bit again I borrow. Here I fix 0 in this one, and in the next one I am going to fix 1. That's it. So now we got experience. Then slowly you realize that remaining 500 we can give here. 0 0 1 0 1 1. You know, this 0 here, here 1 here. X dot 1 2 3 4 5 6 7 8. We'll see these two things at a time. Now fix This 4 bits definitely fixed. Now 110 is fixed for network number 3. 111 is fixed for network number 2. Okay, sorry, network number 4. This is network number 3. Now let me ask question number 1. How many variable bits we have? 1 here, say 8 here. 8 plus 1, 9. Then 9 bits can, generate 2.9 patterns, which is 512. Here also this 9 bits going to generate 512 patterns. So 500, 500 sufficient, correct? So finally, what is this network ID? Simple. 12 dot 23 dot. See, where is network part? 0 0 1 0 1 1 0, right? Only this X part is, host part. So we have to keep all zeros over there for network ID. So this will be 32, right? 128, 64, 32. This will be, 16, 8. This will be 4, correct? 32 plus 8, 40. 40 plus 4, 44. 44 dot 0. This will be the network ID of this N3. Now what is, slash note, what is this prefix number? Prefix number is nothing but, so we have 512, right? That means 9 bits. For 9 bits, remaining things are prefix bits. 32 minus 9, 23. So this would become 23. Next. So 12.23.001011 up to this point is network ID, correct? So it would be 12.23 dot. So if you see this one, 32, 8, 4, 1. 32, 8, 40, 44, 45. 45 dot 0 will be, because remaining all bits should be 0 for network ID. In that way, we can create another network ID 12.23.48.45.0 slash prefix number is again same thing like this one, 23. So finally we created 4 networks. We started with 2000 first, then 1000, 500, 500. Let's try to understand how many bits we are using for prefix. If you see in the first this one, why 23? Because host part was 9. This one also host part was 9. That's fine. Now easily we can understand that there are 512 addresses here, 512 addresses here. Here this prefix is 22. 32 minus 22, 10. That means, so 2 port and 1024 addresses we have in this network. The next one, 21 here. 32 minus 21, that is nothing but 11. So 2048 addresses we have in this network. So perfect. Now slowly you try to understand this one. Initially it looks tedious and everything, but once you get experience, if you do 2-3 times this same thing, then very easily you can do it. It's all about practice and understanding how to split them. That's it. Okay.